Hello, so welcome to this lesson about the confidence intervals and p-value for the tests on the population variance. So firstly, we are going to look for the confidence interval. So the same as previously we have seen, we can construct the confidence interval to test our hypothesis. So this is the chi-square distribution. We have the acceptance region in the middle. Here we have this critical value, and here we have the right critical value in case we have two-sided tests. We have alpha over 2, here is the blue area is the rejection area. Also we have alpha over 2, the blue area to the left, which is also the rejection area. So the probability that the chi-naught square falls in the acceptance region is 1 minus alpha. For example, if alpha is 5%, we have the acceptance possibility of about 95%. So we have this relation. We can substitute instead of chi-naught square with the equation. We have n minus 1 as degrees of freedom. We have the sample variance divided by the hypothesized population variance. So we can rearrange the equations and inequalities to have finally this interval, which is the confidence interval on the variance in case we have two-sided tests. So sigma square, or the population variance, will be bounded by a lower limit and upper limit, which we are confident at a confidence level of 1 minus alpha. So this is in the case of two-sided test. We have the sigma square confidence interval between two values. This is like the lower limit and this is like the upper limit. So in case if you have one-sided test, we have larger than in the alternative hypothesis or less than in the alternative hypothesis, we can also compute the confidence interval. In fact, the same methodology as the two-sided test. Here we have this side is the same as in one-sided. We only changed alpha over 2 to be only alpha, because in one-sided test we have totally alpha in one side. Here we have alpha on the right side. Also here in the case of less than, we have alpha to the left side of the chi-square distribution. And the same here for n1 minus 1. Here we have n minus 1 and n minus 1. Also we have s square and s square s square. We have also the chi-square, which is the critical value in the denominator. We have the chi-naught square we have chi-square value, critical value in the denominator, the same as before. So this is in the case of two-sided test. We divide alpha into alpha over 2 to the right and alpha over 2 to the left. This is the critical value, which is in the left side of two sides. This is the critical value of the chi-square to the right side of the two-sided test. So the blue region is the rejection region. Here we are going to reject the null hypothesis. Also here in this area we are going to reject the null hypothesis. In the in the white area in middle, we are going to fail to reject the null hypothesis, or this is the acceptance region. This is in the case of two-sided test. But in case of one-sided test, we have alpha completely in one direction. So if we have larger than in the alternative hypothesis, we have alpha completely to the right. So here we have the critical value for chi-square to be chi-square alpha and n minus 1. n minus 1 for the degrees of freedom, and alpha here means the area under the curve to the right of chi-square is alpha. So the area under the curve from this point until positive infinity is alpha. So this is the rejection area where we reject the null hypothesis. This is the acceptance region where we fail to reject the null hypothesis. The same if we have the alternative hypothesis as less than. So here in this case we have the alpha to the left side of the chi-square distribution. We have this critical value as chi-square of 1 minus alpha and n minus 1. We have n minus 1 for degrees of freedom. We have 1 minus alpha, which means we have the area of 1 minus alpha to the right of this value. So the area under the curve to the right of this value will be 1 minus alpha, or the area to the left of this critical value will be only alpha. In the white region, this is called the acceptance region, or here we are going to fail to reject the null. Only here we are going to reject the null or H naught. Also, we can use the p-value to examine and check our hypothesis. But in fact, the p-value can only be estimated from the chi-square table. We don't have a methodology to get the exact value, except using exact calculations from equations or using some software like Minitab. So using some software like Minitab, as we will see later, can give us the exact p-value. So here we have the same methodology to check the hypothesis using the p-value. If we have the p-value to be less than alpha, we are going to reject the null hypothesis. Otherwise, we are going to fail to reject null hypothesis in case the p-value is larger than alpha. So now let's have the same example for the noise variance. We have taken 30 points or 30 readings. We have calculated the sample variance to be 3.8. So S square is 3.8. We have the same hypothesis to be, we have the null hypothesis sigma square, which is the initial assumption for sigma square, to be 2.5. We are afraid if the variance or sigma square is larger than 2.5. We are also going to use the same confidence level of 95%. So we have calculated previously the chi-naught square to be about 44. So this is a one-sided test, as we have seen. This is the critical value of chi-square, alpha, and n-1. This is the acceptance region. This is the rejection region. So previously, using this statistic of chi-naught square, we have rejected the null hypothesis. Now we are going to use the confidence interval to see what will happen. So this is the chi-naught square, 44. This is the critical value here for rejection, which is 42.56. So using the methodology of confidence interval, we have this interval for sigma square or the population variance. By substituting for n-1 to be 29, we have the sigma square value 3.8. We have also chi-square value to be 42.56. So we are going just to substitute here in the equation. We have the confidence interval for the variance to be sigma square is larger than 2.59. So now our duty is to look for the hypothesized variance. Our hypothesized variance is 2.5. So is 2.5 included in this interval? In fact, no. 2.5 is not included in the confidence interval. So this means we will reject the null hypothesis. The confidence interval we have from 2.95 until positive infinity, because we have larger than. So 2.5 in fact is not included in the confidence interval, so we are going to reject the null hypothesis, which is the same conclusion we have seen using the test statistic. And finally, we are going to estimate the value of the p-value from the chi-square table. So we have seen this before for the chi-square distribution. We know that alpha is 5%, number of sample is 30. We have seen the critical value for chi-square. We have seen the chi-naught square to be 44. Now let's use the chi-square table. So in chi-square table, we are going to use the row of 29 for degrees of freedom, because the sample size is 30. So we have degrees of freedom to be 29. So now we have the chi-naught square to be 44 approximately. We are going to find where does the 44 lies in between which two values. So we have the 44 lies in between these two values. We have 42.56 and we have 45.72. So because here we have one-sided, so the p-value will be the area under the curve to the right only. So the p-value is the area under the curve to the right of 44.08. So the area from this brown line until positive infinity, and the area under the curve is the p-value. So from the table we have the p-value is less than 0.05, which is the value here, and the p-value is larger than 2.5%, which is the value here. So here we know that the p-value is less than 5%. So because the p-value is less than alpha, alpha is 5%, we are going to reject the null because the p-value is less than alpha. So this is only an approximate value for the p-value, but the exact value can be got from some software like Minitab. Using the Minitab, as we'll see later, we are going to calculate the p-value. We found that the p-value exactly equals to 0.036, which is less than alpha of 0.05. So using the p-value methodology, or using the confidence interval, also using the test statistic of chi-naught square, so all these methodologies have led finally to reject the null hypothesis.